Today we're going to work on the rules and procedures for multiplying fractions against whole numbers, multiplying fractions with fractions, and how we can multiply mixed numbers. So we're kind of putting together a couple skills into one. And the first thing I want to do is go through some examples following our steps for multiplying a fraction with a whole number and then a fraction with a fraction. I want to specifically talk about two different options on how to solve this. The first thing I want to do is go through option one. In option one, we're going to multiply straight across, and then we're just going to simplify the fraction. We're going to reduce it. Now, if I have a whole number, any whole number is a fraction over 1. So the first thing I want to do is turn any whole number into a fraction. So I'm going to take 6 here on my example and make it 6 over 1. In option 1, I'm just going to multiply straight across. 7 times 6 is 42. 12 times 1 is 12. And what I would do now is I would reduce the fraction. I would ask myself, what is the biggest number that is divisible by both 42 and 12? And the answer is 6. So I would divide both by 6. 42 divided by 6 is 7. 12 divided by 6 is 2. Now that this is reduced, I want to turn it back into a mixed number by dividing. 7 divided by 2. 2 goes into 7 3 times. There's 1 left over, and I read it like I would read a clock going from the 12 to the 6 to the 9, and my answer is 3.5. Now, that is option 1. My preference in teaching is always to try to simplify the problem before I do any actual multiplication. So I do something called cross-canceling or cross-reducing. I'm going to rewrite the problem. 7/12 times 6 over 1. And when I cross-reduce, I want to look at the problem like I'm looking at it in an X shape, diagonally. And what I want to ask myself is, are there common factors that I can reduce by dividing both of those numbers by the same number? So I look at 7 and 1. I can't do anything with those numbers because 7 is prime and it's over 1, so therefore it's as simplified as it can be. But when I look at the 6 and the 12, they have common factors. So what I would do is I would ask myself, okay, what can I divide 6 and 12 by? 6 is the biggest number, so 6 divided by 6 is 1. 12 divided by 6 is 2. Now, I go back to option 1 and multiply straight across. 7 times 1 is 7. 2 times 1 is 2. And then I would divide like I did before to turn it back into a mixed number of 3 and 1/2. Okay. Next, I'm going to go through option 1 first and then show the steps for option 2. In option 1, I'm going to multiply straight across. 3/8 times 10/15. 3 times 10 is 30. 8 times 15. 8 times 5 is 40. 8 plus 4 is 12. So I've got 30 over 120. Now, I would use rules of divisibility to reduce this fraction. Ask myself, what's the biggest number I can divide both of these by? I know I can divide it by 2, 5, 10. In this case, I can actually divide them both by 30. And 30 divided by 30 would be 1. And 120 divided by 30 would be 4. So my final answer would be 1/4. Now, to take away a little bit of a step and to simplify it in my eyes, I want to cross-cancel first. I want to cross-reduce. So I'm looking at the 3 and the 15 before I do any multiplication, and I'm asking myself, what can I divide 3 and 15 by? I can divide them both by 3. 3 divided by 3 is 1. 15 divided by 3 is 5. So 3/15 becomes 1/5. Next, I look at the 8 and 10, and I ask myself, what can I divide 8 and 10 by? Well, they're both even, so I know I can divide them both by 2. 8 divided by 2 is 4. 10 divided by 2 is 5. Now I'm going to multiply straight across. 5 times 1 is 5. 4 times 5 is 20. And I want to reduce that fraction if possible. I can divide both of these by 5. 5 divided by 5 is 1. 20 divided by 5 is 4. As you can see, whether I multiply straight across and reduce, or whether I cross cancel first, I'm getting the same number. What I'm trying to accomplish by cross canceling first is to cut out a step and simplify my math a little bit. All right, my next two examples, I want to work on the steps for multiplying mixed numbers. The steps for multiplying mixed numbers just adds one extra step to the two steps I just did. Before I can do any multiplying straight across and reducing or cross canceling before I multiply and reduce, I've got to convert the mixed number into an improper fraction. So in my first example here, I've got 2.5 times 5. Well, we know that 5 is the same as 5 over 1, so I'm going to put a 1 under there. Now what I have to do is I have to convert this to an improper fraction. I'm going to take my denominator times my whole number, so 2 times 2 is 4. I'm going to add the numerator to make that 5, and I always keep the denominator of 2. So this becomes 5 over 2 multiplied by 5 over 1. Once I've added this step and I've converted from a mixed number to an improper fraction, now I can cross cancel, multiply across, and simplify. So I ask myself, is there anything that these two have in common that I can cross reduce or cross cancel? I can't do anything with 5 and 1. I can't do anything with 5 and 2. So I'm going straight across. 5 times 5 is 25. 2 times 1 is 2. And my last step would be to simplify it, to convert it back into a mixed number. Since I have an improper fraction, 25 divided by 2. 2 goes into 2 once. 2 goes into 5 twice. And I have 1 left over. So my final answer would be 12 and 1/2. 12 and a half. Okay. Now my last example, I've got a mixed number multiplied by a mixed number. First thing I need to do is turn them into an improper fraction. 6 times 3 is 18, plus 2 is 20, and I always keep my denominator of 3, times 4 times 1 is 4, plus 1 is 5, multiplied by 5 over 4. Now I'm back to what I did in my first two examples. I can go straight across if I want to and multiply and reduce, or I'm going to try to cross cancel, cross reduce if I can. I'm looking in an X shape. I look at the 3 and the 5. They're both prime numbers. There's nothing they have in common that I can divide by. I look at the 20 and the 4. I see that they both can be divisible by 4. 4 divided by 4 is 1. 20 divided by 4 is 5. Once I've cross-canceled, now I can multiply straight across. 5 times 5 is 25. 3 times 1 is 3. I've got an improper fraction, so my final step would be to convert it back into a mixed number by using division. 25 divided by 3. 3 goes into 25 8 times. 8 times 3 is 24. 1 left over. I read it like I'm going around from a clock from the 12 to the 6 to the 9, and my answer is 8, and 1/3 is my final answer. Okay? So to wrap up, most important thing, the skills that you have to be successful. You need to be able to reduce, okay, using rules of divisibility. You must be able to take a mixed number and convert it to an improper fraction. And you must be able to make sure that your math facts are good so that when you are multiplying straight across after you've either cross-canceled, or if you do that step first from option one, that you're getting the correct answers.